In many parts of the world, an annual ritual is setting the clocks ahead in the spring and back in the fall. This began during World War I with the goal of decreasing energy use on the home front. But the change back and forth also plays havoc with our circadian rhythms, leading to a short-term increase in everything from traffic accidents to heart attacks. Many people and governments are therefore suggesting we just stick to one single time throughout the entire year. We know that an increase in general activity can greatly decrease the risk of illness and death. This is especially important in children, as early behavior patterns often set the tone throughout one's entire life. In today's episode, we'll take a look at whether a permanent switch to daylight saving time and more waking daylight hours can naturally increase physical activity. Can something as simple as staying at daylight saving time with later sunsets really increase overall physical activity? In a northern country such as Great Britain, staying at daylight saving can mean more than 200 extra waking daylight hours a year. Having these daylight hours in the evening can be especially valuable, as that's when many of us are not at work or school and have more leisure time. The total amount of daylight hours stays the same, but does increasing the daylight waking hours result in more physical activity without our needing to do anything else? To answer this, we would need to directly measure physical activity throughout the day. If later sunsets cause more physical activity, we would also expect that increased activity to happen in the later afternoon and evening, rather than evenly distributed throughout the day. It would be especially useful to measure physical activity levels in the days before and after switching to daylight saving time for a direct comparison. This is what happened with a 2014 study analyzing 15 large studies that tracked physical activity in children throughout the day. In total, more than 23,000 children in 9 countries were studied. Activity was measured directly using sensors worn by the children throughout the day, and this was matched to the times of sunrise and sunset. Factors such as temperature, sex, age, weight, and also maternal education as a proxy for socioeconomic status were also studied. This graph shows the activity level on the vertical axis and the hours of the day on the horizontal axis. We see that, regardless of the time of sunset, the level of activity was very similar throughout the day up until mid-afternoon. After 1500 hour or 3 p.m., we start to really see a difference in activity. In particular, the dark dashed line is when sunset is earliest. From there, the later the sunset time, in gray, then yellow, and then red, the more the physical activity. The later the sunset, the greater the total daily activity by a small but worthwhile amount overall. This was also consistent across all individual factors, so it wasn't just one group like older and wealthier boys shifting the entire results. This was also true when looking at the days right around shifting clocks forward and backwards. So overall, data like this suggests that a permanent shift to daylight saving time throughout the year may be an easy and natural way to increase physical activity. This extends a bit beyond our usual focus on environmental physiology, but I hope you still found it fascinating how we can use big data to really understand the question and help inform public policy. My name is Dr. Stephen Chung, and I run the Environmental Ergonomics Lab at Brock University in Canada. We publish short videos on different topics in environmental physiology every Wednesday. Thanks for watching. I'll see you next time.